Welcome to Algebra 2. Today we are going to be solving exponential functions. In order to solve exponential functions, we need the base numbers to be the same. So, if we have 4 to the 9n minus 2 equals 256, this first base number is 4. We need to somehow write 256 as a base of 4. So we think of our exponents to the fourth power. So 4 to the second is 16, 4 to the third is 64, and 4 to the fourth is 256. So we're going to use 4 to the fourth, and we're going to replace 254 with 4 to the fourth power. So there we have 4 to the fourth power, and that's equal to 4 to the 9n minus 2. Now the reason why we want the base numbers the same is because if the base numbers are the same, then the exponents have to be the same. So once when we have the same base number 4 here, we can just jump and say, well, then 9n minus 2 should equal 4. And now this is a very easy equation to solve. So we'll add 2. So we have 9n equals 6. Divide by 9. So n is equal to 2/3. And there we solved it. Okay, next one. Here we have 3 to the 5x is equal to 9 to the 2x minus 1. So we want the base numbers to be the same. This one is 3, this one's 9. Well, we know 9 is 3 squared. So 3 to the 5x is equal to 3 squared to the 2x minus 1. So here we replace the 9 with the 3 squared. So now that we've done that, we can go ahead and just set the exponents equal to each other. So 5x is equal to, we can distribute the 2 throughout that parentheses, so 4x minus 2, and now solve. So we subtract the 4x, so x is equal to negative 2. So there we solved it. And one more of these type. 5 to the 3 minus 2k is greater than 1 over 625. This has a base of 5. This is 625. So if we think of our exponents of 5, 5 squared is 25. 5 to the third is 125. 5 to the fourth is 625. Now because this is 1 over 625, we know 5 to the negative fourth would be 1 over 625. So we can replace it. So 5 to the 3 minus 2k is greater than 5 to the negative fourth. From here, we can then just solve this by looking at the equation that's formed with the exponents. So here our exponents say 3 minus 2k is greater than negative 4. Now we just have to solve it. So we subtract 3 from both sides. So negative 2k is greater than negative 7. Divide by negative 2. Since we're dividing by a negative, our sign will switch. So k is less than 7/2. So there we solved it. Now I'm going to give you 2 points, and we're going to write the exponential function for those 2 points. So our 2 points that were given are 0, 128, and 5, 371,293. Now, one of the points, it's critical that we have the point here at 0, 128. Because when we have our graphs of exponentials, we know 0, 1 is always going to be a point if our a value that we're given is 1. So here what this tells us is that because we have 0, 128 really, in order to get from 1 to 128 we have to times it by 128, so this tells us that our a value is 128. Okay, we get all that from just that one little point. So now if we think of what our parent function looks like, our parent function of exponential graphs is y equals a b to the x minus h plus k. Well, we just figured out what a is 128, And we are not going to worry about the translations. We're going to assume that it wasn't translated. So we know y equals 128 b to the x. And from our other point now, we now have another point that we were given, which is 5, and then 371,293. We're going to plug this in for our x and our y value in our function. So we have 371,293 for our y is equal to 128 times b to the x, or to the fifth. We're going to solve this. So to solve this, we first have to divide both sides by 128. So when we divide 371,293 by 128, we get 2,900.726, and it keeps on going. So this is equal to b to the fifth. And then we learned from a few units ago, the way how we get rid of the fifth power would be to take the fifth root of it. So when we take the fifth root of 2,900.726, we ended up getting a value about 4.926. So now we can write our general function of y equals, our a we know is 128, times our b we just got to be 4.926 to the x power. Many times when we put that 4.926 in parentheses, it makes it much clearer that that's where the multiplication is. So 128 times 4.926 raised to the x power, that is our exponential function.